This is an introduction into UmXplorer. With UmXplorer, you can investigate the capabilities of the UniMocX system. If you take a look, the very top portion of the screen gives you a chart which shows a number of different parameters that come from the simulation. There are tabs across the top of the chart which allow you to see different values. In this case, the pressures, right now we're seeing the aortic pressure, pulmonary artery pressure, right atrial pressure, and left atrial pressure. If we click on the volumes button, we're able to see the volumes of the various chambers in the circulatory system: aortic volume, pulmonary artery volume, right atrial volume, left atrial volume, right ventricle volume, and left ventricle volume. So you can see how those change in time. Flows allow you to actually see flows through certain elements of the simulator. In this case, we've got the mitral valve, aortic valve, systemic flow, tricuspid valve, pulmonary valve, and the pulmonary system. You notice this little bump here on the top of this flow. That indicates the atria when they contract. You see it's on both the tricuspid valve and the mitral valve. Positive going flow is flow out of that, or in the positive, normal positive direction of that particular element. PVAD, pressures and volumes and flow, these are for the pulsatile VADs. SVAD is for continuous VAD, or a spin VAD as I call them here. TH pressures, that's for the total artificial heart. You'll note that we're seeing some, even though we don't have a total artificial heart implanted. That's because in the simulation, the ventricles are shared between the artificial heart and the biological heart simulations. So you'll see some pressures there, even though you don't see, even though we don't have a TH implanted. Volume, same situation. You'll be able to see some values even though we don't have a TH implanted. The bottom portion of the screen gives you the ability to change various parameters of the simulation. In this case, we're looking at the heart. We can easily implant an artificial heart just by using this button over here. We'll go ahead and do that, and you note how the volumes chart changes. Essentially what you're seeing here is the left ventricle blood volume, left ventricle air volume, right blood volume, right air volume. You note that as the air volume increases, the blood volume decreases. Essentially we're displacing the blood in the ventricle with air. That's a normal operation, obviously, for the artificial heart. This is a syncardia artificial heart. Same deal. Now we are able to see pressures in the TH pressures tab. You note that the structure of these pressure waveforms are consistent. They are consistent with the companion 2 driver. If we change the kind of driver that we're using by clicking this button down here, regulator driver is essentially the same as the big blue driver from syncardia. And you'll note you get some changes in the structure of the waveforms, pressure waveforms. Volume driver, that is a simulation essentially of the freedom driver, which is the mobile driver used for the artificial heart from syncardia. And you'll note we get even more changes in the pressure waveforms. If we take a look at these values here on the right hand side, you get to see some important values having to do with the operation of the simulator. Let's go back to using a biological heart. Go back to the pressures here. Let's give the patient a cardiomyopathy. Essentially what we're doing is these reference volumes here, and you can read about those in the guide. We'll go ahead and increase those reference volumes, essentially giving the patient a larger heart and one that is not as capable of contraction as it was previously. We'll do that on the right side also. These are the right ventricle and the left ventricle that I'm manipulating here. And you note that we're down to about 21% left ventricle ejection fraction, 26% right ventricle ejection fraction. If we further change these minimum reference values, those things will drop even further. Now we're down to critical values that we need to do some intervention on this particular patient. If we go into the, so this is essentially how you make your changes that you want. If we go to the other tab in this area, we can change resistances, mitral valve resistances, aortic valve resistances, etc. You'll notice that the valve resistances have a forward and a reverse value. In this case, the reverse value is 100, which is essentially infinite in the system. And what that means is that there's no backflow. If we go ahead and go to the flow screen here, and we take a look at the mitral valve signal, everything is positive going. We have it go from 11 to 0, so there's no backflow. If we change the reverse flow resistance, you'll note that now we have a fairly substantial backflow. And essentially all we've done here is make it so that we have mitral valve insufficiency. So as I said before, we have a patient here with very low ejection fractions. So let's go ahead and implant a balloon pump. And you know we get the characteristic waveform on the aorta of a balloon pump implanted patient. Notice we're getting some clipping across the top here, which means that we are overfilling the balloon. So we'll reduce the systemic pressure, drive pressure on the balloon pump, get that down to about 120. And you know we soften things up, and so we're no longer stretching the aorta with the pressure of the balloon. Now we can intercede with this patient with a continuous VAD or a spin type VAD. In this case, when you click on these things, these are going to be set up to be initially simulating a Thoratec HeartMate 2 device. So we'll go ahead and implant with a ventricle input for the HeartMate 2 device, and you'll note that we get a substantial increase in cardiac output. We still have this pulsatility up here, which should be a warning that something is wrong, because with a Thoratec device you shouldn't have much pulsatility. The reason is because we still have the balloon pump implanted. So let's go ahead and stop the balloon pump, and you'll note that we are immediately transitioning to a pulseless flow through the aorta. And we can go ahead and, instead of using a continuous VAD, we can use a pulsable VAD, something like that put out by Berlin Heart or one of the older Thoratec devices. And we'll go ahead and implant with an atrial input. You know, we get increased cardiac output as one would expect, but we do get substantially more pulsatility than we would with a continuous VAD. And so you can see what the flows are like when you do that. You can see the structure of the flows change quite a bit. If you use these buttons right here, if you make a change and you want to speed up the simulation for just a second or two, you can click the equilibrate button. The equilibrate button essentially allows the simulator to run at full speed, which is a little bit faster for a short period of time so that it can equilibrate the patient. The reset button takes you back to the defaults, and so you're back to just a normal patient.